afternoon, everyone. Today we'll discuss about the topic that is vector calculus, and the subject is antenna and wave propagation. So wave code is KEC 603, and we'll discuss about the topic that is vector calculus, and this will discuss about the differential elements in cylindrical, spherical, and Cartesian coordinate system, and if time permits, we'll also discuss about the integrals. To start with the differential element, first we will talk about the constant coordinate surfaces in the Cartesian coordinate system. If I say x, this one is y, and this one is z. So this plane, if I talk about, there are three variables x, y, and z in the Cartesian coordinate system. If we talk about x is constant and y and z are the variables, then a plane or a surface will form. Clear? If I say one variable varies and other parameters, or you can say other parameter, or you can say other x's are constant, then a line will be formed. Let's say how. Now if I say x equal to 5 and y equal to 3 and z varies, so you will see here at x equal to 5, let's say if x equal to 5 and y equal to 3, this is 3 and this is 5, so a line will be formed which is in this direction. So this one is the line when x equal to 5 and y equal to 3 and z will vary. Clear? Now if I say similarly, if I say two parameters are vary and one is constant, so a plane or surface area or surface is formed. That depends which of the parameters constant, which of the parameters varies. Clear? Now if I say, let's say this is x, this is y, and this is z. If I say x is constant and y and z are variables, x is constant, y and z are the variables, means the surface will form in the yz plane. The surface or a plane will form in the yz plane, that is this one. Clear? Now if I say y is constant and x and z are variables, then x and z are the variables, means the plane will form at this point. Clear? And if I say z is constant and x and y are variables or varies, this plane will be formed in the xy plane. Clear? Similarly, in cylindrical coordinate system, that is rho, phi, z, if I say two are constant, let me change this one. This is rho, phi and z. If I say rho and phi are the vary and z is constant, then a plane or a surface will form. And if I say phi and z varies, rho is constant, then a surface will form. And if I say rho and z varies, a phi only, rho and z are the constant. Rho and z varies and phi is the constant, then a surface will form. Means line is formed when one parameter varies and two parameters are constant. Clear? And surface will form when two parameters varies. Actually, these are not the parameters, these are the coordinate points, and one is constant. Clear? Now see, if I say rho is only constant, if rho is constant, phi and z varies. Means if I say rho is constant, then a cylinder will form and this curve, a circular cylinder will form, means this one. Now if I say phi is constant, it means an semi-infinite plane will form along its edges along a z surface. Means phi is constant, this one, when phi is constant. Means if I say this is a cylinder and if I cut it through this one, when phi is constant, then a plane will form which is visible to you. Okay, like this one. So semi-infinite plane will with its edges along a z axis. If I say z is constant and rest two parameters are variables, then a infinite rectangular this surface will form. When z is constant, this height z is constant and phi and the rho are varies. Clear? Similarly, in the spherical coordinate system, r, theta and phi. If I say r is constant, theta and phi are the variables, a sphere with its center at the origin will form. Means this one. If I say theta is constant, when I say theta is constant, top to bottom is constant, then this theta is constant and what phi and rhos and radius is variables. So this area will form when this theta is constant. Clear? And when phi is constant, same plane will form, this one, when phi is constant. So in the vector calculus, we will talk about the differential elements. Differential elements consist of, we'll talk about the differential length, differential area and the differential volume in rectangular, cylindrical and spherical coordinate system. If time permits, we will also talk about the line integral, surface integral and the volume integral. So first of all, talk about the differential element in the rectangular coordinate system. Now see, let's say this is x, y and z. When I talk about the differential element in the differential, we will talk about the differential length, differential area and the differential volume. So first of all, we will talk about the differential length. Differential length is the smallest length. If I say a large line is there which cannot, I have to talk about the small element in that line, that is a differential in that length, that is a differential length. If I say this is vector A, and if we talk about this is L, and this A vector is equal to AX, A cap X plus में AY, A cap Y plus में AZ, A cap Z. Clear? So if I talk about the differential length, that is DL, which is measured by this DL. This DL will be equal to what? This will be equal to AX, means A in the X direction, that is will be equal to DX A cap X plus में Y, this is Y, and the smallest element in this Y is DY A cap Y plus में, this is, if I say this is Z, the smallest element in the Z is DZ, so this is DZ A cap Z. Clear? Now in the next, if I say this is a differential normal area, differential surface, and this differential surface is generally made up of what? This differential surface is generally made up of when one parameter is constant and two parameters are variable. Clear? If I say if we talk about this one, the whole surface is there. This one is the whole cube. If I talk about the smallest element in this surface is this one, which is also made up of what? Cube. So if I say this point P, the smallest element, this at this point, this whole cuboid is made of a small number of cubes. Means if I said a smallest cube or smallest cuboid which is having length, what? This is will be what? dx, this is dy, and this is dz, because this is y this is x, and this is z. Clear? So you will see here there will be 3 planes will be formed. One plane will be this one, other plane will be this one, and third plane will be this one. So in the first, this one, if I say talk about this one, so this plane having area will be equal to what? Will be equal to CD multiply by AD, and this CD is equal to what? If you say this CD is equal to what? dy multiply by dz. This is what? dy, this is dz, and this is dx. So this area will be equal to what? dy into my dz. Clear? Now this differential surface area also consists of what? This dy ds vector equal to dy into my dz. This also consists of the unit vector which is perpendicular to the surface directed outside the volume. Means this can be, if I say this is front of cube, if I say this is a wall, so yeah, or you can say this is screen. The perpendicular to this plane will be this one end, or inside the screen or outside the screen. So this can be equal to plus minus a cap. Which direction? That is equal in the x direction, means perpendicular to the YZ plane. Clear? So if I talk about this plane, so this plane will be equal to what? Dx into my dz, and perpendicular direction vector which is perpendicular to this plane will be in this direction or in this direction, that is will be equal to plus minus a cap phi. That depends on the whether it is will be a plus or minus, that depends on the volume, that we'll talk about after later. And for this plane, this is equal to dy into my dz, dy into my ये मैंने आपको गलत बता दिया, dy into dz तो हो गया. This is dy into में dx, dy into में dx, dy into में dy into में dx. This is x. This will be x. dy into my dx, and plane will be your perpendicular to this one, that is plus minus a cap z. Clear? So now for the differential volume, this whole volume will be equal to what? dv equal to dx into my dy into my dz. So this I have told you about this surface. 3 planes will be there. This is the plane, this one is this side, and this one is the. Now next one is the differential element in the cylindrical coordinate system. Now see, if I say this is a point P, this point P is passed through a cylinder. So if I take the transformation of this P, that is at this point P, P. Clear? Not P exactly. So this angle will be phi. This is rho, and this one is Z. So dz is equal to this one. D rho will be this one, differential element in terms of rho. Clear? And d phi will be this one. If we say this one, this element is d phi. Clear? So this is d phi. Clear? Now if we talk about the unit vector at this point, a cap z will be in this direction. A cap rho means this. If I say this is rho, so a cap rho will be in this direction, and phi, if I say this is phi, so phi will be in this direction. Clear? Now see, first of all talk about the differential length. Length will be equal to what? This point P at this point will be equal to what? D rho into में a cap rho, D rho into में a cap rho plus में dz into में a cap z, and this differential length will be this one. This length is equal to what? Length of arc, and this length of arc is equal to radius multiply में what? This radius multiply में d phi, that is equal to rho into में d phi, and a cap phi will be in this direction, that is rho into में d phi into में a cap phi. Clear? Now differential surface area. Is given by, will be the multiply of these two parameters. Clear? Now if I say, if you talk about this surface area, there are three planes will be there. This one, this plane, and this plane. So first of all, we'll talk about this plane. This plane is equal to what? In this z is varies and phi varies. When z and phi are varies, means what will be? Rho into में d phi. Clear? Rho into में d phi and dz vary. Rho into में d phi dz. Direction will be vector direction or unit vector direction will be equal to perpendicular to this one, that will be into में a cap rho. Clear? So this plane will be equal to rho into में d phi dz a cap rho. Clear? Now if I talk about this one, so this one will be equal to what? In this dz is very, phi is constant, same phi is constant, but what? Rho varies. dz into में d rho into में dz into में a cap phi, and this a cap phi will be equal to minus of a cap phi. Clear? Now next one is the, for this plane, d rho varies and what? And phi varies. For the phi varies, that is rho into में multiply by rho into में d phi, and unit vector direction will be equal plus this one plus of a cap z. Clear? And the differential volume for the all the side differential elements multiply will get the overall differential volume, that is rho into में d rho into में d phi into में dz. These are the differential normal surfaces. And for this differential elements in spherical coordinate system, we'll talk about in this we'll talk about in the next lecture. So in today's lecture, we have talked about the constant surface in coordinate system, that is in spherical, cylindrical and the Cartesian coordinate system, and we have talked about the differential surface, differential length, differential surface, differential volume in the cylindrical coordinate system and the Cartesian coordinate system. The book which I have referred for preparing this slide, that is Principle of Electromagnetics by Matthew and Sedico. Thank you.